There we go. Is that better? Yeah. Cool. Okay. So the purpose of this meeting is to get a summary of the work that each pipeline has done on the EDA. As I said, we've seen some fantastic work in the Slack channel. People have really been collaborating across different groups. The group leads have done a really, really fantastic job. And, I was looking forward to the final sort of presentation of these results, because the EDA will lead on to the feature engineering, and the feature engineering, that part is very dependent on the EDA. Because that's where all the insights come from. So that's where the experiments in manipulating different features and joining them together and whatnot comes from. So I don't want to take up too much of your Saturday, so we'll just crack on. Is there anyone here from Group 1, Prediction RTC Severity, that would like to share their findings with the rest of the group? Let me just make sure you can share your screen as well. You should have access to share your screen, so whoever would like to share, please go ahead.
I think, unfortunately, Ibrahim, who has been doing our EDA, is unable to make this evening. I can quickly pull up his the work that he's done, which is very good. I just need to get it open. 1 second. Okay, can everyone?
I'll turn my camera off just for bandwidth. Yeah, we can see your screen, Michael.
Great. So Group 1 is doing, we're just looking to predict road traffic collision severity. So we're trying to determine which, essentially which features are more correlated with road traffic severity. One of the things that we have kind of noticed is that road number, both first road number and second road number, are relatively varied and pretty much arbitrary. They kind of span mostly because they are names and numbers for these roads. They're not they're not prescriptive in any way. They don't provide a significant portion of information. For location information, we're planning on keeping longitude and latitude present. This is a second road number, which is very similar in terms of the information. For carriageway hazards, one of the things, the vast majority of incidents take place, and there seems to be no hazard present on the road itself. There doesn't seem to be. Ibrahim broke up date into day of the month, and also the month, to look at that data a little more closely. There doesn't seem to be significant variation in terms of the number of accidents per day of the month. The 31st does have a little bit of a drop off, and that just simply has to do with the fact that there are not every month has a 31st day. And so that accounts for the kind of differences that we're seeing in that. And kind of similarly, it seems like there's not a ton of variation in the number of fatalities on any given day of the month, which lines up. Ibrahim did a quick look at the severity based on month. Yet again, not a lot of specific variation. However, looking at the fatal accidents, there isn't anything that jumps out immediately when we looked at fatal accidents by month itself, but when you break up fatal accidents by season, we can actually see that autumn has about almost 500 more accidents than 500 fatal accidents than any other season. We're going to do some additional EDA on this specific some multivariate analysis on this. We want to try and see if we can't pick out where this additional increase is coming from, if it's maybe related to weather conditions that were also like road conditions that we can also pick up in the data as it exists already. The vast majority of accidents are slight accidents, meaning that they are non-fatal. It's mostly bumps and scrapes. There does seem to be a slight increase in on day of the week. On the weekends and Fridays, there seems to be an increased number of fatalities. What was that?
Did someone have a question then? Sorry.
Yeah, go ahead.
Or was it just an accident? I don't think it might have just been an accident. Everyone's on mute. Go
on. We also looked. Ibrahim also looked at like the division of accidents based on what time they happened during the day. As kind of one would expect, overnight when there are fewer drivers on the road, there do seem to be significantly less accidents. And the times that kind of correlate towards like morning rush hour and evening rush hour seem to have a higher incidence of accidents, which is probably related to the significantly larger number of cars on the road at those times. We looking at kind of the junction control, which is whether or not there's a police officer or a stop sign or an automated traffic signal. We see that the vast majority of them have data is missing or out of range. After looking into this a little bit further, it turns out that data missing or out of range is also indicative of there just simply not being a traffic control. Like essentially, if it's a straight piece of road, there would not be any traffic control there, essentially. And so it seems like that bit of data is a little bit convoluted. But unfortunately enough, there's not going to be an effective way, I think, to parse out that information. How are those bins grouped together? These are the categories that were provided within the data itself. We haven't done any additional in the previous for the time. These are grouped based on hours. So this is from midnight till 1 a.m. Like these are hour by hour. This is 1 to 2, 2 to 3, 3 to 4, 4 to 5, and so forth and so on, going up to the full 24-hour span. Similarly, junction detail just kind of is indicative of how many roads there are present. It seems like the vast majority of accidents are actually happening not near a junction. They're happening kind of. It appears that they're happening mostly like on open roads. You show how the hour column is created. Yes. So the hour column initially Ibrahim has converted the time feature, which is present in the data set originally. He converted it to a date time object, which allows you to tease out the hour component of that date time object. And we created, in some ways, we feature engineered an hour column that Ibrahim added to this, allowing us to do the analysis based on that portion of the data. We looked at light conditions. It seems like for the most part, much like we looked at already with the time information in and of itself, since most accidents are happening during the day, most accidents are happening in the daylight, which means that kind of logically these two things kind of fit together. There does seem to be a small, there seems to be proportionally, there seem to be a larger number of fatal accidents for accidents that happen in the dark. So there are a lot of accidents that happen in daylight, but proportionally, it is more dangerous to be driving in the darkness, because even though the number of accidents that are happening then is smaller, if an accident is happening, it is proportionally more likely that it will be fatal. And so that is an important piece that we can kind of pull out of looking at this graph where we've broken that out.
I have a doubt over here.
What?
I have a doubt over here. How you have why you have differentiated dark? Could you show the previous graph? Yes. Darkness, no lighting, and darkness, lights, unlit. How these two are different?
So based on our research looking at the original source of the data, it appears that darkness, no lighting means that there were no lights present on the road, and darkness, lights unlit means that it was dark out, but the lighting on the road either hadn't come on yet or had failed. So I think it is to differentiate from when the police are doing their report for these, I think it is to differentiate between whether or not this just happened on a road that should have been dark or on a road where there was a light present, but that light was not lit. And so no lighting versus lights unlit seems to be the differentiation. The one that we were unable to get any additional information on was darkness, lighting unknown. That one was unclear, but there's remarkably few of those as a portion of the total data set anyway. So much of this information is what is being collected in these accident reports, and so these are just the options that are available to the officers who are responding.
So I think the situation is same now. If lights are unlit or if there is no lighting. So if we look at the situation, it is dark. So what I did in this analysis, I merged these two columns into a one, and then I have done my analysis.
I mean, that is certainly something that you could do. I don't. For the analysis that we've done, we have left it separated, and I think the reason for that is that, at least the reason that I would continue to keep them in this manner is that I do think that if the people collecting the data have specifically called out that this is a separate thing, it may be important to be like for remediation purposes, like if they're looking to fix this thing, if you have lights that are present, and they're unlit, that maybe is a repair work order or something for the local municipality to respond to. And I think it would be important to kind of understand that is a danger that needs to be addressed. So I think that it still remains somewhat pertinent to the data entirely. I don't know, because like I said, because there are there's so few of that feature category, I don't know that it's going to have a particularly robust impact on the model in the future, or even particularly much on the EDA as it currently stands. Moving on to weather conditions, it seems like most accidents seem to happen in just normal weather. It does seem like it doesn't seem like there seems to be, like, since most accidents we've already looked at that happen during daylight hours, it kind of follows along that, like, a lot of them are going to happen during relatively okay weather. An interesting thing that we could look at or continue to look at would be the proportionality of like how many fatal accidents per accident for each category, which we haven't unfortunately parsed out just yet. The number of casualties, just this is essentially injuries and fatalities, kind of included in looking at, like, how more or less how many people are being injured in these things. It seems like the vast majority are in the single digits. Most accidents are only having a couple of people. There are some outliers that kind of exist within this. There are a couple that have 60 plus casualties, which are the interesting thing is that they're outliers in that they are well beyond the standard deviation for the 3 times standard deviation for the data set itself, but they are real traffic accidents, and so I think that it's still important to catch them. I think that it would be important to, in pulling this out for people for further analysis, it would be good to pull out actually these individual cases, since there's a relatively small number of them, and actually look at those as individual case studies instead of as a part of the larger data process. These are things that are particularly bad because of the number of casualties that existed, and so it would make a lot more sense to pull them out and see, if these are the worst things that can happen, what are the things that we can identify in these that would be easy to remediate so that we can improve safety. And because if you eliminate something that has 60 casualties, that might be more effective than eliminating something that has 1 or 2 casualties, depending on the number, what the defect is for that thing. And similarly, number of vehicles has a very similar kind of distribution, where the vast majority of accidents road traffic collisions are happening with a relatively small number of vehicles. And similarly, there are just a handful, about 15 total accidents which have essentially 5 or more vehicles involved, which means that most of them have 1, 2, 3, or 4 vehicles involved. So again, this is something that I would break out these individual pieces for case studies, to be what were the conditions that led to these, these are clearly outliers, and so they're a special case, and so it might warrant in this particular data set to kind of evaluate them separately. Most accidents are happening on single carriageway, which I think this has more to do with. I haven't been able to find the data or put the data together yet for this, but I would assume that this distribution would match up with the distribution of the roads, the types of roads themselves that are present in Great Britain. You would expect that there if there is more single carriageway, you would expect them to have a higher proportion of the total number of accidents. And so that is, something that we are hoping to be able to collect some data on. We had discussed doing a couple of other, like I said, some more multivariate analysis, looking at where weather, or using some of the time-based or seasonal-based data that we had that seemed to lead to a couple of insights. We were hoping to get a little bit more working towards that, but we don't have that ready at the present time. But that is where we are at so far. Does anyone have any questions?
It's fantastic work. Great observations in that pulled from there as well. I was in your team meeting yesterday, and the discussion spot on. There's a number of different things that wouldn't be obvious until you've done this sort of analysis, and it's I think as well, because we're all using the same sort of data, so each group will probably have the same sort of insights, but some of the insights will also be in the direction of their particular solution or the particular question that they need answering. But understanding that what everyone's done, we can confirm that some of the insights are true across all data groups, and they have to be taken into consideration. Very good work. Is there any questions for Michael at all? No, I'll take the silence as you explained it very well, Michael. Thanks very much for that. I can't see anyone from Group 2 in the call at the minute. Has anyone been working with Group 2 at all and is able to show anything? If not, I'll just have them share it to the Slack channel. But I can't see anyone on the call. If not, it's no big deal. We can jump over to the time series group. Has anyone got anything that they'd like to share from the time series group, the EDA process? From the Slack channel, there was a couple of good insights that we were seeing. Chandler had a good few. But has anyone got anything to share at the moment? Feel free to share your screen.
So hi Rich, I have done some EDA, but that is not complete. So if you want, then I can share that.
Yes, please go ahead.
Okay. So I hope my screen is visible.
Yep, you're all good.
Okay, so since we are doing time series EDA, so we have been provided with the different data sets in which we had data from 2005 to 2017, and so I have these are just data manipulation I have done over here, and next, I'll directly jump to the data visualization, and what I have done, I have analyzed the accident severity on date-wise, month-wise, quarter-wise. So as we can see from 2005, this is 2005. From 2005 to 2018, slight accidents are decreasing, but we cannot see any drastic change in this serious accident and fatal accidents. And next, if we look the accident severity on the month wise, so again we can see the same trend, and over here we can see some amazing pattern that on October, November, December. On this months, we are getting peaks in every year. Like from this to, if we have from this range to this range, we have a year. So October, November, December, every time we are having a peak over here. And this is over here we are having peaks. Over here we are having peak, and the same pattern we can find from 2005 to 2017. So as Michael has pointed out, this might be due to season or whatever it is. So we need to find that. I have also made observation on this. if we look on the quarter wise, because I was having intuition that it is on looking on the data set, I found that on the last quarter of the month we are getting a high number of accidents. So I split the data on the basis of quarters, and again I found that slight accidents are very much in this last quarter. From in every Q4, we can see that of a given month, of a given year, we have a higher number of accidents, and the same trend we can see from 2005 to 2018. If you look at this serious accidents and fatal accident, there is they are not changing, but this slight accident it is changing. Uh, year wise, if we have a look, then total number of accidents, obviously slight accidents is decreasing, and there is no change in the serious accident and fatal accidents. Well, there is change, but that is very small. Like it is 25,000 in 2005, and it is 22,000 in 2017. So as per my observation, it is not changing drastically. Then I have accumulated all the accident in like the January month, January, February, March, April, and month wise. I have calculated the accidents, and I couldn't find any pattern over here. So, and again, if we look at the quarter wise, if we accumulate all the accidents in quarter wise, so again fourth quarter has maximum number of accidents. So this part I have done, and I was analyzing the accident on the basis of time, like on which hours the accidents are, on which hour of the day most accident is likely to happen. So this was I was doing.
Cool. Thank you very much. Good work. It is a curious one. We're in the fourth quarter,
yes,
start of autumn. It is quite curious, and you know, I wonder why that is. I mean, my sort of first thoughts were that, you know, from the British summertime to go to autumn, the change in weather is quite drastic. So I wonder if people, you know, don't really adapt to the changing weather conditions, which causes more accidents. Because certainly in the winter, when the weather's really bad, a lot of people won't drive, so there's probably less people on the roads. They might, you know, opt for public transport and whatnot rather than drive themselves. And I wonder if that increase in slight accidents and whatnot is reflective of that. It's quite a curious one. It's something that I wouldn't have thought, to be honest with you, because you know you would, you know, I mean, obviously you tend to drive a lot safer in bad weather conditions or not drive at all. So that's pretty much a good explanation. But that transitional period between summer and winter is quite an interesting one. It is quite interesting. So, and you know, obviously we've seen this pattern now across the data in you know, for two different sort of pipelines. So yeah, it is a curious one. We could look into that a lot further. But yeah, fantastic analysis. And you know, we can see from the time series data, you've got a lot more years to play with, and we can see the trends a lot clearer. So yeah, that was good observation and good work so far. Let me just take a look. Yeah, Chandler did a bit of analysis as well, and he's posted his notebook that he's uploaded to Kaggle on the Slack channel. If anyone would like to go and take a look, Chandler, you're more than welcome to present it. But if you're not comfortable doing that, we can catch it up another time. That's not a problem.
One more thing I want to ask over here, like the way I'm doing this EDA on the time series, is it correct way, or do I need to add few things, or I have to like what are the shortcomings in this?
It's a correct way to do, because with our time series analysis, we want to develop, you know, we want to recognize patterns that occur over time. We want to say what is a curious observation as well, that even though most of the variation is in the slight accident group. It is curious that the fatal and the the sort of medium accidents, the serious and fatal, they don't really change across the board. I mean, they have reduced over time, yeah, admittedly, but it doesn't seem as drastic as the patterns that the slight accidents are showing. And that is, why is that? It seems that the same amount of fatal accidents are happening, and it does call for more sort of experimentation within the data, and to research further into what's going on. What are all these fatal accidents? What have they all got in common? What isn't being changed to mitigate them? That is quite curious, and it is definitely one to look. Someone's asked if you could share the source code of your notebook. So please, upload it to the Slack channel and let people take a look.
Okay, I'll do that.
That would be great. Salman, have you got any comments on the work you've seen so far?
This is amazing.
Your input.
This is amazing work, and both Michael and Dhananjay was presenting this one. Yeah.
Dhananjay.
Yes. So I mean, both of them look really amazing. In terms of time series wise, yes. Right now we are looking at kind of like the target column and what is happening, what are the trends and things like that. And technically, this is what we have to look, because when you deal with time series analysis, or when you're dealing with time series data. So the idea behind is basically there are 4 things that you need to look for: the seasonality, the trend, and so basically. When we are modeling time series data or something, those are the things we kind of like need to kind of like address before we get to the modeling part. So far, I think you're in the right direction. You can still play with certain other kind of like if you're doing. What I was saying is basically you can still play with it by adding different kind of like more columns. For example, like I don't know if we have a column for a type of tire. Means, for example, like based on the seasonality, I can see that if we don't have a column, that means getting that information would be a good idea to collect whether they had their tires for the winter changed or not, or something like that, because that would give a very good indication. So I don't know whether it is part of the data or not, but that is a good recommendation in our part that we figured out that maybe during that particular phase, if we can collect that information, that can also give us a bit more slight information that whether the tire change is making the difference or not. So by just doing that, so that can be one of the recommendations based on what I saw that. And what Michael presented, I think Michael is saying that Ibrahim and Michael. So yes, both of them have done really amazing job. I was very enjoying both the presentations. So it's obviously everybody has their own perspective, and I always respect Michael's perspective because Michael is an experienced person, and he knows what he's doing. So all his insights were on spot. Some of the things I was not able to observe myself, but when he talked about it, that was amazing. So that was amazing. Yeah.
Cool. Yeah, just to reiterate what Salman said then, part of feature engineering as well is not just dealing with the data that is in front of you. Feature engineering can also include going away, researching on maybe some extra data that you could supplement the original data with to make it more meaningful. Finding out what kind of tires these vehicles had on would, if it's possible, that would add some insight. So feature engineering part is also about that. And, if you can find data sets that will enhance the data you have, by all means do it, and it will only lead to a stronger model. It's part of being a data scientist and machine engineer. It's being resourceful as well. If you are in if you're in industry and you need to build a model for a client for some sort of solution, and their data engineers can't provide you with data that isn't necessarily useful, it's up to you to be a bit more resourceful and try and source data from elsewhere, or go through their sort of data engineering team and see if they can, pull any more insight for you. So yeah, that's part of the experience. You need to be resourceful. Nothing is served to you on a silver platter, and it can be quite frustrating sometimes, but it can be enjoyable if you source a bit of data that you didn't think that existed, that could enhances your model and makes it exceptional. It's a win. It's a win for everyone, and the satisfaction you have with that is incomparable to anything else. So yeah, it's a very good idea. That's part of feature engineering as well, and hopefully, if we play our cards right and we take a look at the Department of Transport's data dumps, we might be able to take a look at that and find something that imbues our data with a bit more validity and whatnot. So it's a very good idea. Okay, we've got 1 minute remaining on this, so what I'm going to do is refresh, and if everyone can jump back on, we'll go to group 4 for their presentation, because I believe they've got an absolute doozy ready for us based on what they've just posted in Slack. So yeah, I'll see you in a minute. Always, you've got your hand raised.
Yes, sir. So, sir, I've noticed that most of the people from our Slack server are using the raw data sets that you provided to us in the beginning. So, I mean, the data set that were resulted from the feature pre-processing stage are not used, and that's more. I think part of it is because some of the features in the column, like categorical features, we were unable to impute them properly. And then, as far as I have seen, so some of the categorical features, like there were a lot of missing values in it, and like Salman sir already told us that we could not use ordinal encoder in that case. So using it, but if for the next stage, feature engineering phase, which data set would be used for that? Like if I want to contribute in that phase, so which data set will I be using?
The data set you would be using, it depends what group you want to be in. The prediction severity, they're using the data that yourself and Vivek provided, and it only runs up to 2010. The only two groups that are using the data which is beyond that are the time series and the geospatial group. They're using the full 2 million lined data set, because to get a good time series, the more years the better. And if you group 1 are using the original data set that runs to about 2010, once we build a predictive model, we can test that model on data from a different distribution and see if it holds true. That's the only reason why. So group 1, let me just double check what we're using. Yeah, group 1 are using the original data set that you and Vivek provided, and group 4 are using the original vehicle data that you also provided as well. It's only group 2 and group 3 that aren't. So dependent, I mean, you're more than welcome to work in any group you want, even more than one at a time. That's absolutely fine. It's open to everyone to do that, to jump in and out each group. I advise it because you're probably going to learn more, because each group has a completely different process to reach the end goal. So yeah, if you're working in group 1, it's the original data that you and the data engineers produced, if that clears it up.
And I would add one more thing in here. So that's a good question, always, because what you can do is you can, since now you have different notebooks where you can see different visualizations and everything, you can throw in different data sets. For example, like the one which is not being encoded, the one which is being encoded, and look at the distribution of different things. See whether one particular encoding technique changes the distribution or not. Because when we are doing encoding, we don't want it to change our distribution of the data. So you can compare them. So if you want, means that would be a good research kind of a thing where you would understand better what happens when you apply a one particular encoding technique. Does it change, or how does it change the distribution of the data? So I would recommend you to play with that. Means since you already have the notebook, you can just put in different data sets in those notebooks and keep those two graphs side by side. The same graph generated by ordinal encoding, the same graph generated by the other kind of encoding or something, and see whether the same categories, how the distribution changes in a big way or not, because we don't want big differences. When we are doing encoding, we should be able to get the same distribution of the data as we originally have. So that is a good thing. You can play with that, and I would recommend you to play with it. Yes, other than that, what Rich said, that if you are working on certain thing, so stick with his recommendation. But in order to learn more, you can visualize or throw in different data sets, and you can compare them. And this way you would be able to see what kind of changes a particular encoding technique does on the distribution of the data. Yeah.
Absolutely. Yeah. Does that answer your question, always?
Yes, sir. Sir, I have one more question. It is a little bit out of the domain of today's meeting, but I was watching a tutorial course today on the internet, and it was talking about a tool by IBM, IBM Watson Desktop. It is actually used for the whole process of machine learning, training a data, and then building a model and then deploying it. So I'm familiar with the training up to the modeling phase, but I have never deployed a model. So and today in the Slack channel, you were talking about Streamlit, that you will be using Streamlit as a tool for deploying the model. So I was just wondering that is there any benefit of using Streamlit over IBM Watson tool, or because
No,
if I want to
yeah, there's no, to be honest with you, there's a number of different ways we can deploy our model. It just depends what we want to do. See, what I had in my head was that we would create a Streamlit app or a Flask app, and what we can do is basically have a mini website with all our observations on there about the traffic on the UK roads. We can have our time series analysis. We can have interactive maps where we can zoom into certain areas of the country and see the accidents over time using the data that we have. We can make a inference model on there and have it where we can, we could upload a batch of test data and it spit out predictions. And, it could be like a one-stop shop dashboard, which is either static. So we can, so it'd be sort of like the government website where they have all the data and all the work goes on in the background, and then they provide imagery, they provide visualizations about the data that we've got, and we can write a report for each group's findings and host it on the Stream app. It just depends how we want to go. And what we have available in terms of time, but there's no each method of deployment has their own pros and cons. Yeah. I just said the Streamlit app because it is for beginners, especially. I think Streamlit and Flask as well are quite easier to deploy things with. They're quite powerful, and the documentation for both Flask and Streamlit are absolutely fantastic. It just depends how we got, what we want to do. What is our solution? Is our solution to be informative, or is it our solution to provide a interactive sort of place where a local authority can take all their accident data and batch load it into a model, and it makes if they could synthetically create situations and they want to measure if there was an accident there, what is the most likely outcome? They could take a batch of that synthetic data and upload it to our Streamlit app, and it'll spit out the predictions saying, the synthetic observation 1, based on our data, would tell us that it's going to be a fatal accident. And they can use that then to maybe plan traffic solutions. If they're building new roads, they can input that sort of data and see, well, if we go with a certain junction, it's most likely going to be a fatal accident, so we can't use that junction in that particular area. that is, that is an option that we can do, but we could do a lot of it and have that, have a solution where, yeah, we do have our observations and people can read the reports, read our intuition, read our EDA analysis and what we've done, but also at the same time, local authorities can make predictions on any sort of new traffic management they want to use. So yeah, it's a very, we've got a number of different solutions that we can go with, and Streamlit and Flask are probably the easiest to implement that with. Are they going to be the be all and end all? No, we could explore other avenues, but that is just from a beginner's perspective. That was my recommendation, but we don't have to follow that, of course.
And it is free as well. So
it's free. Yeah.
And it's free. So if you go with any cloud service or any kind of like AWS or IBM or Google Cloud or Microsoft Azure or something, you would need to pay money in order to use their instances or some things like that. Which means Streamlit and Flask. First of all, even though all those things are also easy, but Streamlit is pretty straightforward. Pretty means it is so easy for the beginners, and it is very good way to kind of like make. You don't even have to get your own website. You can just deploy it on Streamlit's website, and you can put it in your portfolio. And anybody who is looking at your portfolio, you can give them link and they can go and play with your app. So that is one big thing that and it is all for free. So best thing is it is free and it is very easy to use. That is the reason why, since we have a lot of beginners, so that is the reason why we were talking about that. But yes, if you want to explore Microsoft Azure, AWS, IBM Watson or something, we would be happy to kind of like jump in and help you in any way we can. Yeah.
And also as well, what I want at the end of this project is something that you can share with people and show that you've worked on a particular, project. If we have a Streamlit app that's deployed to Streamlit, it's always going to be there and it's always going to be hosted. It might not be live anymore, but at least you've got a demonstration of something that you've put together, and you can brag about it. You can put it on your LinkedIn and say, go and take a look at this project I've worked on, because that's fundamentally why we're here. It's to improve you and to improve your prospects. And if you've got that on your resume and you can share a link to something that you've built, it's going to help you a lot in your career. So that is the sort of idea behind it. I tell you what then, we could talk about this all day. Let's jump to group 4. Group 4, would you like to present? You should be able to share your screen.
Yeah, Rich, can you hear me? Yeah, let me screen this. So is my screen visible?
Yep.
Yeah, okay. So we have prepared a slide too, right? Okay, hello everybody. This is me, Shravan Bral, and we are the group 4 presenting the vehicle analysis. And the main problem statement of this pipeline is to do the in-depth analysis of vehicles involved in collisions. And some of the objectives of our EDA was to explore the data set, right, features, and explore if any duplicates and missing values and unwanted entries exist, because we used both the data set which was imputed and the original data set, so we could gather some more insights, and we perform some of the correlations and asking some business related problems. So let's go with the one which we used from here. It is a notebook which uses the imputed data set that comes from the data engineering guys who provided us. And the features, first of all, when going through the features and getting access to the data dictionary, we could categorize intuitively by we categorize into accident specific features and some features related to vehicles, and some of the features that were more related for a condition for a vehicle to be involved in an accident, and some of features those were related to person or the driver driving the vehicle. And yeah, we found some extra fields that signified the imputed feature column. And when going through the data set, what we found was, yeah, most of the features that we had was categorical and a lot of boolean fields, and yeah, we didn't have a lot of numeric fields. And this above analysis showed that we don't have any enough numeric features, and most of them are categorical. So we need effective strategy to analyze them and convert into numerical values. And moreover, the given dataset comprises of only vehicle and passenger related information which were involved in an accident. That implies we don't have any entries apart from vehicles involved in an accident. We have a pure dataset, and then we felt it like solving a novelty problem, or we need to gather some data, or we need to create or synthesize the data ourselves to further evaluate our analysis. So that's for the later part. And when going through, so the first thing we found was numerical columns, the numerical columns such as vehicle location restricted lane. So when going through this feature, specific feature, we found that the minimum and 50% quantile range and 75% all are zero. So this posed weirdness. And when we got through the data dictionary, it was actually not a numerical column. It was actually a categorical column to signify where was the position of vehicle. So it was not actually a numerical. So we need to handle it differently. So this posed next query, that if we should believe the imputed data set or not, because while imputing, was that the side effect that caused the vehicle location restricted lane to have such imputed values? So yeah, and we got through the original data set, and when going through, we could see that most some common missing patterns from this figure. And to analyze this, uh, yeah, we've created a dendrogram which shows that which of those features together got missing. So from here we can see that this features such as was vehicle driver left-handed or right-handed is missing along with junction location, and together they are missing, the values are missing along with journey proposed. So this poses a question that was this a error while recording the data? Right. So they was this an error while recording the data? So it posed a question on that. And further, we found that when correlating all these missing values, we saw we have seen that these features such as was vehicle driver left-handed or right-handed, and junction location with journey propose of driver, propulsion code with engine capacity are highly correlated. So the first week data engineering, the data set which they imputed, I think this analysis has not been included. So the imputation might have caused different anomalies in the data set. We believe that it has surely caused so anomalies, because these things has to be considered. And yeah, we checked that what are the most unique values, which features have most unique values. So we see that engine capacity has high cardinality, and yeah, and vehicle location restricted lane, as we have seen that it has all the values. Look, we can see most of the values are zero, so it doesn't count anything for the analysis. And age of vehicle also, and engine capacity, we see a lot of skewness. We might see a lot of skewness in engine capacity and age of vehicles. So when after going through the non-numerical columns, we find that one interesting thing is that from the data set, one of the accident index that identifies a specific accident has involved at most 53 frequency. We can see the same accident index, right, in 53 rows. That means we have 53 vehicles, unique vehicles involved in an accident. So that might be a serious accident because, or it might be some error or some kind of disaster. So there is involvement of 53 vehicles involved in a single accident. And most of the things such as towing and articulation, we see high occurrences of no towing and articulation. And yeah, vehicle did not leave carriageway. And most of the accidents while driving were due when vehicles were going ahead together. So, and yeah, interestingly, most of the vehicles got into an accident was car. And yeah, and moreover, the most of the accidents where most of the accident happened from the front side of a car. And when going through more of this, we could see uh, the most frequent columns, features having most frequent values where was vehicle left-handed or drive or towing and articulation, as this is the similar kind of thing that we can see in the graph. And yeah, we can see some of the features, and it is we are sure that we can generalize some of the thing from the data set that vehicle driver are mostly right-handed, and mostly the cars and vehicles are not used for articulation or anything. So towing and articulations might not pose the serious, might not be the exact factor to cause an accident. This is our intuitions. And another thing is, yeah, most of the accidents are happening by are skidding and overturning. It's by skidding. And going through some of the quality investigation, yeah, the guys who provided us the imputed data set doesn't have any duplicates, and none of the columns have any missing values. And yeah, and if we go through the content, mm, it is the similar kind of thing that we can see. The particular thing we can see here is the yearly the number of accidents has been rising, right? We can see it. and and a peculiar thing is the number of vehicles that have been involved in an accidents lie within the range of 0 to like from 1 to 20 years. And the vehicles above 20 years might not that involved in accident, right? And yeah, and we can consider some of the features to remove, such as vehicle location restricted lane, as I've said, and vehicle reference. The interesting thing we found from vehicle reference is that, first of all, we thought the vehicle reference would signify a specific unique vehicle in whole data set, but it was not like that. We will see it in the further analysis down below. And yeah, these were some of the correlations. It might be good if we visualize them. Yeah, and some of the questions that we are asking from the data set was like, what was the direction of most of the vehicles during an accident? So most of the accidents happened when the vehicles were going ahead together, and turning and taking a turn, or slowing down. So in these conditions, we might need to think. So what may be the reasons for vehicles having an accidents when going ahead together? So this might help to further analyze what might be the reason for the road accidents, right? And this is very interesting because we gather insights from data, and we can help the individuals make conclusions and policies accordingly. And the second question was, which company vehicles are more involved in the most of the accidents? And interestingly, we found that Vauxhall and Ford were having a high frequency. And if we if we take some of the four to five vehicle companies, then we see about 40% of accidents. I think these all of the vehicles are the top class vehicles. Yeah, so top class vehicles as we have analyzed. And yeah, and we gather some of the insights by grouping the make and model. So it will give us some insight more about which companies, which model got into an accident. But overall, we think it might not help, but it might help for the specific vehicle company to consider for if their vehicle model is better or not. So And what is the mean age of vehicles involved in accidents? So this is an interesting point, because as we had discussed with the bridge earlier, that 7 years, about 7 years of age of vehicles, right? They are involved in an accident more, and newly and nearly 7 years aged vehicles. And the more we go farther, like the more old the vehicle becomes, it is less like it the pattern sees we can see the pattern that it is less likely to be involved in an accident. As Rich has said earlier, that uh, those classic cars, they might not they might drive it carefully or might not take out. Yeah. So most of the vehicles in the Liverpool could be like classic cars, and they might be not driving. So that might be a reason. And some of the things like what type of vehicles to be involved in most of the accidents. So we can see cars are one of the most vehicles that involve in an accident. And yeah, and some of the interesting anomaly we can see is here is the ridden horse. So this poses a question that ridden horse might not fit in the vehicle, right? Or if it is fitting, then we found another pattern that ridden horse had engine capacity of about some value. I think there is in the below, but yeah, the ridden horse had some value CC associated with it. I think that value came from the imputation. Our best guess was if this instances of ridden horse were null, then due to imputation they might have got the value. And yeah, and some of the things, um, like a reference. Yeah, and yeah, the another thing that I was wanting to say was the vehicle reference. We thought the vehicle reference was a unique reference to a vehicle, but it was not. It was just a unique reference for a vehicle for a particular accident, and this feature didn't give us any information. And mm, is a vehicle, and yeah, and from the other notebook that we had used from the original dataset, uh, it also gave us some of the information such as so some of the things that we noticed was average age of vehicles is 7 years, and majority of vehicles are under 13 years. But the maximum recorded vehicle age was 111. So I don't know how this value was handled in the imputed dataset. And maximum and minimum value for engine capacity seemed ambiguous, because we have the minimum engine capacity as 1 cc and maximum as 96,000. So even that 96,000 value or valued instance had only one vehicle recorded. So in further feature engineering, so some of these insights could be used to either ignore these values or columns. And yeah, if you go through further, and we see a lot of skewness in engine capacity. So one of the things that our friend analyzed was there might be a problem while recording engine capacity, because when going through online articles and finding about the company's vehicle models and their respective capacities, engine capacities, so it didn't match with what we had in the database. So I think we need to correct it accordingly, or need to handle this skewness accordingly. Uh, and some of the things such as just a quick summary that that most of the accidents happen in the urban area, that is sure to be. And Some of the information gave by journey purpose of driver didn't give any sort of knowledge or information to us. And most interestingly, as discussed earlier, that most of the accidents happened not at or within 20 meters of junction. But if we combine all of this, then if we make a radius around the junction, then junction has a lot of. If we make a perimeter around the junction, then junction has a lot of frequent accidents happening. And yeah, and most of the vehicles uses petrol as their energy source. And yeah, that those were all the insights that we have gone through. And let me go through some of, if we have anything from here. Mm, excellent.
If you could share that presentation with the group, that'd be great.
Sorry, Rich. Can you
If
repeat it?
if you could share that presentation with the group, it'd be
Okay.
fantastic, because it's nice and quick to
Yeah.
see the information on there. Has anyone got
Okay,
any questions about that analysis at all, or any observations? Yep, fantastic job.
I had one quick thing looking at the manufacturer data, and also there was something else. I wish I'd written it down. But I think it might be interesting to maybe compare. So like Vauxhall and Ford, many of these companies, are simply selling more cars. It might be interesting to provide a comparison against how many of those cars are registered or were sold in, during the period when this data was collected, just to see how closely it matches up, like proportionally. Like you would expect, like, if there's, a million Fords on the road, but there's only 5 BMWs, you would expect that there are going to be more accidents with Fords than BMWs. I understand that the data is not present here, and I think Rich kind of touched on this earlier. Some of these things are things that, like, you might, it may not be available, but it can't hurt to go and look at, like, the British, like, just Google, like, government, UK car model registrations or something like that, and just see if any information pops up. I think that might provide at least a little bit of insight comparatively for for this, because I think that data in a vacuum could possibly, cause, if you're looking to predict the likelihood of a car being in an accident, I think that you're going to need that comparative data to provide a jumping off point for the model.
Yeah, because that's called a base rate fallacy. We need to understand the baseline of how many vehicles of a particular model on the UK roads. There's plenty of data on that, and I can safely say Ford and Vauxhall are probably the most common. So yeah, you would assume that they would be in the most accidents simply because there is more of them. But yeah, it'd be an interesting analysis to see that comparison. But yeah, it's been some great work there, and it'll be interesting to see what sort, the sort of models of the vehicles that are involved in the accidents was also a great insight. Has anyone got any other questions about the vehicle data at all? Let me just pick up on what we were saying about the horses and things like that, and the electric motorcycles. In the UK, if as I think always put it in the chat, if you are commandeering any sort of vehicle and there is a driver on the UK road that is classed as a vehicle, and that does include horses. The interesting observation as well was that the cars that were in the majority of accidents were 7 years old, and it's quite a a significant portion of the accidents as well. I think it was 22% off the top of my head. That is massively, pretty much treble anything else, and that is a good observation, because it's what makes a 7-year-old car be more likely to be in an accident. And it'd be interesting to see the distribution of ages of cars that are not in accidents, just so we can make that comparison. So again, doing a bit of further research and trying to track down, the average count of vehicles by model on the UK roads, and the average vehicle age of those vehicles that are on the road, because we're only as good as the data we've got, and at the moment it's a pure data set. It's only vehicles that have been involved in accidents. What does the distribution look like, the ones that haven't been in an accident, so we can make it fair judgments. Wajihad, is that how you pronounce your name? You've got your, sorry if it isn't, but you've got your hand up.
Sir, it's Wajiha.
Cool, I'll remember that.
Sir, I wanted to ask, is the ED analysis part completed? Can we move on to the feature engineering task now?
Yep, so the next stage is the feature engineering. Everyone is going to basically use the insights from the particular group's EDA analysis, and then start to feature engineer within the context of their particular pipeline, and that can be done as soon as this call's over.
Yes, sir, sure. And are we going to use the same notebooks where the EDA part is done, or are we going to start with our own?
You can start afresh with your own, if that's easier for you to do, please do that. But yeah, or include it and just follow on along the EDA notebooks. There's no right or wrong there. You can do exactly what you're more comfortable with.
Sir. Okay, sir. Thank you so much.
Cool. Thanks very much. Chandler, you got your hand up?
Yeah. Hello.
Hello. We can. It's a bit low. The volume's a bit low. I can't hear you at all now. But yeah, everyone's done fantastic work on the EDA. I'll have Group 2 share their analysis as well. And we can, as we've just mentioned, we can crack on with the feature engineering. And that will be, this is the important part. As I say, this is probably going to take, this will be the main focus of not the main focus, but the most complex part of what we've done so far, only because there's a million things we can do based on the insights of the EDA analysis and the data pre-processing. So basically what we're going to have is preparing the data so it can be put into a model, and it can be digested by a model and predict something useful. In terms of the vehicle data, we discussed whether or not we will be able to really predict whether a vehicle is more likely to be in an accident, simply because we've only got the data of those which have been in an accident. So it would make the predictions very, skewed. So another route we can take is using the feature engineering part of it to include more data, or to, combine different parts of our data that we have to make more in-depth insights, and we can present that. We can pretty much go either way on that, but it would be interesting to see, adding more data that we find from checking out the Departments of Transport's data dumps, and see if they've got anything more that can add, or do an external research into, the number of vehicles on the road of a particular model, and especially the ages, since there was quite an observation there. Chandler, go on. Can you?
Hello. Can you hear me now?
Jump on now. Is your mic working?
Hello. Can you hear me?
Yep, we can hear you now.
Yeah. So I noticed in the vehicle data that the accidents from through the years is increasing, but in the accident data it is decreasing. So I wonder what's the relation or correlation between the
Oh,
two.
yeah, the vehicle data, it's not necessarily the number. I think how I understood it, it wasn't the number of accidents over time. It was the number of how many vehicles have been involved in accidents over time. We've got 5 seconds left, so let me just refresh this. Okay. So what we were just Chandler just mentioned that there was a graph in the vehicle data EDA that showed the amount of accidents over time. It was my understanding that it was the vehicles involved in accidents, but I could be wrong. Can one of group 4 confirm what that graph was showing? Because I haven't got the notebook at hand. Is anyone from group 4 on?
Yeah, Rich. Yep.
Is on part of your presentation, there was a graph which showed quite a significant sort of increase over time. And I think I've interpreted it as over time, there's been more vehicles involved in accidents, while Chandler interpreted it as there was more accidents over time. And how does that reflect in our data that we are using for elsewhere? Because we've seen that the accidents have dropped over the years. Can you just
Yeah.
confirm what that's going?
Yeah. Well, actually, as I said, Rich, that analysis was from the unimputed data set, right? So in the unimputed data set, we saw that the distribution as it is rising, the involvement of cars has been rising, and but in the imputed one, we see a slight falling down after 2015.
Okay.
So that
Yeah.
posed a different analysis.
Yeah, that's right. Yeah, that's true. So the imputation has somehow changed the distribution.
Yeah.
But yeah, it is generally the amount of cars involved in accidents is sort of increased. Not necessarily the frequency of accidents, just how many cars are involved. If that's right. Does that make sense, Chandler?
Yeah.
Cool.
Thank you. And one other
Spot on.
question can I ask?
Yep.
So, in my understanding, the casualties in the accident data is the number of dead person.
Mhm.
So yeah, I found that during the I've sent it in the Slack that during midnight there's a lot of uh, casualties or dead during midnight, but the accident is low.
Yeah.
So
So casualties, it's quite confusing. This one. Casualties in the UK doesn't just mean it means deaths and injuries. So yeah, so that's the thing. So that interpretation that might be around midnight. There's going to be a number. People could go out for meals and stuff like that, and restaurants and share taxis home. So there's more people in cars on the roads at that time, maybe, and they've been hit. And the casualties that are in slight accidents, they could be whiplash, a broken arm, a broken finger, or whatever it is. Casualties in the sense of the UK reporting is deaths and injuries. When someone has died, it's usually referred to as fatalities. That's
yeah.
the difference.
Thank you for
It has
clarifying.
caused a bit of confusion because it's just a difference in terminology. In America, if a casualty is a death, it's not an injury.
Yeah.
But in the UK, it's a death or injury. It's just a umbrella term for anyone that was affected.
Thank you. Thank you.
If that makes sense. Cool. Okay. Is there any other questions whatsoever before I let you back?
Hi, Rich. This is Lavanya.
Hello. Hello.
Yeah. Rich, like just a small doubt. It is like for feature engineering, we need to use the versional vehicle data or the imputed one, because I had the confusion. It was not there in the drive. Then later I got the imputed one. So which one we need to use it?
Let me think. So we've already discussed that the imputed one changed the distribution of one of the columns, and one of them columns was the amount of vehicles in an accident. And intuitively, I would say that was quite an important part of understanding, accidents involving vehicles. So what I would do would basically use the raw data set without imputation. And what I'd probably do is try some different imputation techniques and see how that distribution is affected, because we want to get as accurate as possible. We want to match the ground truth, if you know what I mean. So I would experiment with it a little bit and try different methods of imputation and use whatever is the strongest data set, because fundamentally we're only as good as our data. So yeah, that would call for some experimentation, but again, discuss it with the group, and between the leads and the co-leads, I'm sure you'll be able to find a solution and move forward with the feature engineering.
Yeah, because the original data have like missing values. What I say, almost 97% or the 80% kind of. So
Yeah.
that is like it's imputing. It's like just our own data. We are doing it. There is not the raw data will be there for the analysis.
Yeah, well,
So
if you're trying to impute a column with 97% missing values, it's going to be biased. It's going to be, it's not going to be very, it's not going to be very useful at all. But yeah, discuss it with the group and see how to move forward. I'd recommend experimentation, but this is your chance to try a number of different things and see what works and what doesn't. So I don't want to give you too much advice, if you know what I mean. I want you to experiment and learn yourself, but just, come together with the group, discuss the way forward, and hopefully we can you can work it out. But yeah, the next phase, everyone, is the feature engineering, and discuss within the group how you want to do it. Experiments, maybe try and look elsewhere for some more data that will help and supplement the data we already have. Let's just see what we can do. Feature engineering can be quite complex, and there's a million things we can do to the data to try and improve it. But the three keywords: experiments, experiments, experiments. That's what we need to do. Shravan, you've got your hand raised.
One more question, Rich.
Go on.
Yeah. Sorry. Like in the data set, the columns I have seen, like there is other columns with the missing. There it is a categorical like true or a false, true or a false.
Mm-hmm.
That we can impute. We can change it to 0 and 1, and then we can do the EDA part or the feature engineering or the model. This thing,
Yeah, if it's a Boolean, if it's like true or false or whatever, you can change them to zeros and ones. That's absolutely fine. That's not a problem at all.
Yeah, thank you.
No problem. Go on, Shravan, it's all yours. If you're trying to talk, I can't hear you. You might be on mute. Or was it an accident rating? Oh, hello? There you go. I can hear you.
Yeah. Sorry. My question is not that much important, but as you had said that we will be taking 1 week break between feature engineering, right? Yeah, model development. So just to be sure about that. Yeah.
Well, what I'll do. That was going to be we're going to discuss this with the group. Feature engineering is quite heavy. It is quite complex. It might take more time. I will put out a Google form, and basically we can vote on whether we want to take a week break or not. We don't have to. There's absolutely no reason to. I just think, especially for beginners, we can take a week break and we can do more sort of learning and development. Yeah, go on.
I thought it would be better since, as you said, feature engineering part would be taking a lot of time, right? So if we move so fast, then a lot of people can't get what it is happening, right? So if we
Yeah.
take about 2 weeks and go smoothly using both imputed and non-imputed data set, then it would be everyone would be get together to the same pace.
Yeah, I absolutely agree. Yeah, so after the first feature engineering week next Saturday, Salman will be doing a learning and development session on the Sunday with the feature engineering, all about that. So I think over that next week where we have a sort of break, I suppose, we can it'll give chance to people to try it themselves and experiment with different data sets and different feature engineering techniques. So but what I'll do, I'll put out a form anyway and just see how people feel about it. It's great either way, but it's I think a couple of days off and whatnot will probably benefit the beginners, especially after Salmon's Sunday session. So okay, agreed. Okay then, what we'll do, we'll leave it there, and if everyone in the teams can start there gathering ideas for feature engineering, start researching some different techniques, and I will share a couple of resources to the group about feature engineering from a couple of different different websites and different tutorials, and then just as a reminder, Salman will be taking a Sunday session tomorrow, and it'll all be about the EDA process, various different techniques that we've seen and ones that we haven't seen as well. So please, I fully recommend you join that tomorrow. Okay, well, everyone have a fantastic weekend, and I will speak to you soon and in the chat. Thanks very much for all your hard work and your collaboration. We're doing fantastically at the minute, and I'm really glad to see a lot of people collaborating and learning a lot as well from others. That's the point. So great work, team. I'll see you all soon. Bye bye.